Hi, I'm Jim Resch, Sales Engineer Director at BigFix. BigFix is a leading global provider of high-performance systems and security management software for enterprise customers. The BigFix Unified Management Platform provides real-time visibility and control through a single infrastructure, single agent, and unified console for systems lifecycle management, endpoint protection, and security configuration and vulnerability management. BigFix solutions enable customers to securely manage their global IT infrastructures faster and more accurately, resulting in improved governance, control, visibility, and business agility. The marketing people made me say that. Let me try to explain this in a way that makes sense for everyone else. If, like most BigFix customers, you're already thinking to yourselves, we've got a couple of those already. But the problem is we're still not able to meet the challenges of our environment. Our current solutions really aren't timely enough to be able to secure the environment, to meet requirements for reporting. We're unable to manage computers that are not connected to the network. Although they worked well originally, they're really not fitting our systems right now. So let's take a look at BigFix and how that uniquely contrasts to some of the legacy systems you might already be using, so you can better understand how it might complement or potentially replace what you're using currently. The challenge that a lot of legacy systems have when they're dealing with security configuration, monitoring, and management is that they're all built on a central server. That is, the server has all the intelligence and makes all of the decisions. All of the information is collected from throughout the network, brought back to the server, and then through processes or reports that an administrator has to execute, problem identification results or inventory information is generated. The challenge there is that the information needs to be collected across the network. And so what a lot of the legacy architectures have in place is that there are multiple agents installed on each of the managed computers. There might be one agent for inventory, a separate agent for patch management, another agent for security configuration management, and yet another agent that takes care of software distribution and change control. We'll see in just a moment how that contrasts to BigFix. But you can certainly understand why a lot of organizations have a bad feeling about an agent-based technology, because they're used to the system CPU that it uses up, they're used to the disruption that it causes end users. In that legacy architecture, then, those specifically defined agents report up the information that they're hard-coded to retrieve, again, for that reporting process. Because those values are hard-coded, it makes it somewhat difficult to get new and unique values back. Also generates a substantial amount of network traffic as all of that information is transferred back to the central server. So how do those legacy architectures deal with that as the organization grows? Well, typically then, when you go to manage remote locations, they'll often have a mechanism, a distribution server, or a cache and forward point to help with the download files. But communication back and forth between the agents and the server still has to take place across the WAN, generating a substantial amount of network traffic. And typically meaning that those remote locations can't be dealt with in a real-time fashion, but rather scheduled more infrequently than even once or twice a day. So let's take a look at the BigFix architecture. BigFix is a massively scalable distributed architecture infrastructure. Yeah, marketing made me say that one too. So let's again take a little bit of a look to see how that contrasts to what we just learned about. In BigFix, there's only one single agent that's installed on each machine. That single agent performs the ability to retrieve inventory information, security configuration information, and the ability to take actions and make changes on the computer. So one single agent managing the system itself, and specifically limited to less than 1% to 2% of the CPU. So it should be absolutely imperceptible to an end user who's working on that machine or processes that are running on a server. More important, of course, that agent works across various platforms: Windows, Unix, Linux, Macintosh. So for the first time, organizations have the ability to collect information from all of their machines, servers, workstations, laptops, into one central console for review and reporting. Now that agent has access then to virtually anything within the system. However, unlike the other legacy architectures, it doesn't ship the information back to the central server so that problem identification can be made by running reports by an administrator. Rather, the agent has the intelligence to look locally on the machine to identify problem conditions, to see if there's a patch missing, see if there's outdated software, to see if there's a security setting that doesn't meet the required standards. it can identify that locally on the machine so that when problems are identified, then it's able to send simply the computer ID and the ID of the problem up to the server. Minimal communication, meaning that the agent can go ahead and report things in real time. Even more important, what that means, because the agent is consistently, continuously evaluating the machine, as soon as problems are detected, it can be reported, and when authorized, that problem can be resolved. So if you're looking to make sure that certain software is not installed on a machine, when that's been installed, the system can go ahead and take that out. If a user changes a security setting on the machine, the agent will notice that within seconds and will be able to change it back to the security setting that you want. Just as important, because that agent has the rules locally on the machine, along with the policies of how you want that to be handled, that means we now can manage computers that are disconnected from the network. Machines are at home, in hotels, in a hotspot, at a Starbucks. Even though that machine is not directly VPN'd into the network, you still have the ability to maintain the configuration of the machine, dramatically reducing the possibilities that that machine is compromised while it's offline and then brings into the security of your network viruses, malware, or that information could be stolen while it's offline. So now you've seen how the BigFix agent can perform real-time on-endpoint assessment for configuration issues, for compliance issues, as well as provide inventory information. But the question probably comes to mind, how does BigFix know what to look for? How does it know what a problem is? How does it know what security configurations that should be in place? And that comes through the solutions and the extensions that fit on top of the platform that I've just described. And those solutions include pre-written, pre-tested messages that help organizations deal with the common problems that they see. Problems of patch management, problems of security configuration, upgrading and updating software or drivers, but the ability to see what's going on and the ability to change that through pre-written content. Those are the solutions that fit on top of BigFix. So it's the two together, the platform and the solutions, that give our customers the ability for the first time to handle problems as they never have before. Through that scalable architecture, the ability with minimal hardware to reach out to an entire network of computers, for the first time, real-time detection of problems and remediation on an as-needed basis, and for the first time, the ability to manage computers that are off the network. I invite you to look at the other demonstrations to see how BigFix can work for you. Thank you.